Welcome to the Satish Dhawan Space Center SHAR Sriharikota, popularly known as SDSC SHAR. The center is proud member of the Team ISRO, responsible for launching the space missions of India. The space research activities of ISRO were initiated in our country during the early 1960s. Indian National Committee for Space Research (INCOSPAR) was set up by the Government of India in 1962 with the great visionary Dr. Vikram A. Sarabhai at its helm. Indian Space Research Organization (ISRO) was formed in 1969, superseded the erstwhile INCOSPAR. Dr. Vikram Sarabhai, having identified the role and importance of space technology in a nation's development, provided ISRO the necessary direction. Dr. Sarabhai said, "We are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society." The vision imparted by Dr. Sarabhai was absorbed by each and every individual of ISRO community, and the journey towards quenching the thirst of space technology is continuing beyond boundaries. Since inception, the Indian space program has been orchestrated well and has three distinct elements, namely satellites, space transportation system, and application programs. Throughout the years, ISRO has upheld its mission of bringing space to the service of the common man, to the service of the nation. In this process, ISRO has become one of the 6 largest space agencies in the world. ISRO develops and delivers versatile application-specific satellite products and tools to the nation. Broadcast, communications, weather forecasts, disaster management tools, geographic information systems, cartography, navigation, telemedicine, dedicated distance education satellites being some of them. Launchers or launch vehicle are used to carry spacecraft to space, starting from the SLV-3 launch vehicle, which carried 40 kg into low Earth orbit. India today has GSLV Mk3 launch vehicle, which takes satellite of 4000 kg into geosynchronous transfer orbit. India has 3 operational launches: Polar Satellite Launch Vehicle (PSLV), Geosynchronous Satellite Launch Vehicles GSLV Mk2 and GSLV Mk3. The famed PSLV went on to become a favored carrier for satellites of various countries due to its reliability and cost efficiency, promoting unprecedented international collaboration. The Geosynchronous Satellite Launch Vehicle (GSLV) was developed keeping in mind the heavier and more demanding 2-ton class communication satellites. The GSLV Mk3 has the capability of launching 4-ton class of communication satellites. Till July 2019, ISRO has launched 75 launch missions and 105 spacecraft missions, which includes 10 student satellites, 2 re-entry missions, and 297 foreign satellites of 33 countries. The various functional requirements of ISRO is met by its various centers spread all over India. Among all the centers, Satish Dhawan Space Center SHAR is the only spaceport of India. Sriharikota, a spindle-shaped island in the Bay of Bengal, was once a fishing and agrarian hamlet inhabited by the Yanadi tribe, has transformed into a world-class launch base over the years. The vast area, scantily populated and away from the major cities, proved beneficial to locate the launch complexes, solid motor preparation facilities, static testing facilities, and liquid propellant storage facilities all at one place. The sounding rocket complex established in 1969 was used for atmospheric experiments with Rohini sounding rockets and is operational till today. The noteworthy launch is dual-mode ramjet for air-breathing propulsion research. SDSC SHAR houses colossal facilities and plants for solid propellant manufacturing. The first solid propellant space booster plant, called SPROB, has to its credit the processing of solid motor segments for SLV-3 upgraded in times to come to cater to ASLV, PSLV and GSLV. By December 2018, casting of more than 1,000 rocket motor segments was completed in SPROB. To fulfill the demands of solid propellant booster S-200 for GSLV Mk3, which is the third largest solid rocket motor in the world, a dedicated solid propellant plant called SPP was established over the years. Versatility was built into the plant to meet the various demands of launch vehicle program. SDSC SHAR houses facilities for vibration testing, centrifuge and ballistic testing of rocket motors at sea level and simulated high altitude. These facilities cater to the requirements of testing solid propellant motors, which develops thrust of up to 6,000 kilonewtons. The various stages of the launch vehicle undergo preparation and are transported to the launch pad for integration. For the launch of PSLV, first launch pad was conceived, which is operating on the concept of integrate on pad. Complex facilities for liquid propellant servicing, extensive checkout systems were realized to monitor the operations from a safe distance. To reduce the turnaround time between launches, it was necessary to separate the facilities for rocket preparation and launch. SDSC SHAR migrated from its proven concept of integrate on pad to integrate transfer launch when it conceived and realized the second launch pad. Addition of a low bay solid stage assembly building was one such facility done for the GSLV Mk3. This heavier rocket had called for major upgradation of second launch pad systems. The second vehicle assembly building appended to the launch pad will meet the demands of increased launch frequency and ability to integrate future launch vehicles of ISRO. For a launch, the metrology takes continuous assessment of weather. Radars track the launch vehicle continuously to get real-time trajectory. The state-of-the-art multi-object tracking radar can track objects. ISRO transcended the societal application from Earth orbit and ventured into a deep space with the Chandrayaan-1 mission in 2008 to observe Moon from a polar orbit, and appended the lunar research with Chandrayaan-2 that carried, in addition to orbiter, a lander Vikram and a rover Pragyan. It will boldly go where no country has ever gone before, the Moon's South Polar region.
ऋषियों ने उपनिषद से शुरू किया था, आप वैज्ञानिकों ने उपग्रह तक पहुंचाया है.
India became the first country in the world to send a spacecraft that entered Martian orbit in its first attempt. AstroSat is India's first dedicated multi-wavelength space observatory aimed at more detailed understanding of our universe. The reusable launch vehicle technology demonstrator, in its first step of hypersonic experiment on 23rd May 2016 demonstrated many advanced technologies pertaining to autonomous navigation, guidance and control, reusable thermal protection system and re-entry mission management. For extending our arms towards regional cooperation, the South Asia satellite GSAT-9 was launched for SAARC region. Various other complex missions, namely Aditya L1, mission to exploration of Sun's atmosphere, Sukrayan-1, mission to Venus, Avatar, an aerobic vehicle mission, Indian Space Station, etc. are being planned in the coming years from SDSC SHAR Sriharikota.
SDSC SHAR is gearing up to meet the increased launch requirement of ISRO by undertaking projects like doubling the solid motor production at SPRAP through Advanced Solid Motor Production Project, increasing the solid motor stage production at SPP to meet the higher demands of GSLV Mark III, augmenting the second launch pad to meet the semi-cryo requirement, augmenting the first launch pad through PIF project to enhance the launch capacity of SDSC SHAR, making the space theme park with visitors view gallery to accommodate more visitors during launch. The challenges are higher for human space flight missions in orbiting the Indians to space and bring them back safely. For this, SDSC SHAR is putting in place human-rated systems, modification of launch pads and other facilities, meeting the stringent safety and quality norms to meet Gaganyaan mission. The versatile activities of Satish Dhawan Space Center, known as SDSC SHAR Sriharikota, is narrated to you, ranging from solid motor production, environmental testing, vehicle integration, launch pad servicing, pneumatic and liquid fuel servicing of all liquid stages, range operations of radar and real-time network, etc. The activities are being executed meticulously, conforming to all safety and quality procedures for every launch, apart from providing necessary logistic supports from this spaceport of India. We are proud and passionate to meet the growing demands of the country by augmenting the existing facilities and introducing state-of-the-art facilities to meet the future launch requirement and take ISRO to the next level.